I am introducing how to pack and fill a gel filtration column. The main purpose of this experiment is to separate and identify proteins based off the speeds of their elutions through the columns. The speed of their elutions through the columns is mainly based off their molecular weight, where the larger molecular weight proteins elute faster than the smaller molecular weights. I'm going to be describing specifically how to do a G50 Cefidex gel column. First, you want to obtain a burette clamp, and this is where you want to attach the chromatography column with the rubber tubing and the screw clamps attached to the bottom. After attaching this column, you might want to place a beaker below the chromatography column just to catch any buffer that is ran through it. Then you want to pour the Cefidex G50 gel into the chromatography column, and you want to continue this process of adding the G50 gel along with the buffer mix until it is about 15 to 16 centimeters from the white filter paper at the bottom of the column. This is to ensure that you have a long enough column to ideally separate the proteins and tell the difference between them. Then you wait for the gel to compact and separate from the buffer. You might have to do this multiple times. We had to do this around 4 to 5 times, where we let the gel solidify and then elute kind of from the buffer. Then we would take the buffer out and add more buffer gel mix. And you continue this process again until you get about 15 to 16 milliliters of buffer. Then we continued. We ended up at around 15 centimeters of buffer. Then we cleaned our glassware and equipment, and we left our solution for about 4 days, and we made sure to add about 2 to 3 milliliters of buffer on top to stop it from drying out.
Now that our gel is made, we were able to proceed with the filtration. We waited about 4 days to let the gel settle, and then we started off by placing the graduated cylinder under the gel as to measure the point of the first drop of each protein that we separate. We first micropipette off that top layer of buffer, add 400 microliters of protein solution, and then we add buffer periodically throughout the entire experiment to make sure that the gel does not dry out. And then we recorded our values. We found out that there were 3 proteins. The first one was the blue one, which was blue dextrin, and at about 4 milliliters, that's where it started to filter out. In the red, we have myoglobin, and then at about 5.52 milliliters, it was first filtered out. And in yellow, we have flavin mononucleotide, where at 9.1 milliliters, it first started to filter out. Then you continue this process until all the protein is filtered out. We noticed that the first 2 proteins filtered out really fast, whereas the very last one in yellow took a lot longer for whatever reason. And then we recycle the gel and return it back to where we got it, and then clean all of our materials and return it to their locations.